Hi, today I'm going to go over the call stack when it comes to programming. So the call stack is a data structure, a special data structure for computer science that stores the information about the active routines, subroutines, and methods of a computer program. So it's also called things like the runtime stack, machine stack, program stack, or it's just commonly called the stack. So and the way it works is it's almost like having like sheets of paper on top of each other. Like you have a sheet of paper like this, and then you can put stuff on top of it. When you add new stuff, you're adding it on top, and then when you're removing elements, you're removing it from the top. So that's called LIFO. LIFO is last in, first out. So of course, I keep adding stuff in. This top element right here is the last thing that entered the stack, but when I remove something from the stack, I that's the first one that gets deleted. And this is also called pushing and popping. When I'm adding something, that's called pushing. And then when I'm removing something, I'll just do an up arrow, that's called popping. So here I just pushed and here I just popped. So now let's go over the contents of a call stack from a given computer program. So let's say we have this sample Fibonacci program right here. So we have some Fibonacci program, just checks if the number is less than or equal to 1, return 1, and then it'll call itself for the first term to get the first term because the way the Fibonacci works is it's the sum of the previous two terms. So 2 and then 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13, and so on. So that's how the Fibonacci works. So we have the sample program. Now, what are the contents of the call stack? Let's say that we want to figure out the contents of the call stack just before the first time line 5 runs. Let's say just right before the first time line 5 runs. What are the contents of the call stack? Well, let's say the first let's say that the first thing we run is fib3. So we're calling the Fibonacci equation for fib with the parameter 3. So, of course, we call this from main because every program starts with the main function. So in our call stack, we always start with main. Then, of course, in our main function somewhere, we called fib3. That gets pushed on top of the stack like this. So if you think of this as boxes, each thing has its own box of memory. So let's trace what fib3 is doing. So it enters the function. It says if n is 3. If 3 is less than or equal to 1, well, that's absurd. Then we jump straight to line 5. And look at that. That's the first time line 5 ran. So that means that the contents of the stack at the first time line 5 is executed is this, main and fib3. Now, let's change it up a bit. Let's say instead of fib3, we call fib4. And let's say we want to figure out the contents of the call stack before the very first time line 7 runs. So, this is where we get into some interesting stuff. So, the very first time line 7 runs, that's what we want to figure out. So, of course, we have fib4, so n is equal to 4. So, we check if 4 is less than or equal to 1, that's absurd. So, we get to line 5, and we notice something interesting. Now, we call fib at n minus 1. All right, so now we're calling fib3. I'm going to color that in red. Now, this is where we have to be careful. We have to make sure that we're tracing the appropriate function. So now we're not tracing fib4 anymore. We're tracing fib3. So again, we check fib3. N is equal to 3. If 3 is less than or equal to 1, that's absurd. So now 3 jumps over here at line 5, and it calls fib2. And I'll color that in blue, like that. All right, now we got blue. Is 2 less than or equal to 1? Absurd. It's not. We go to line 5. That's getting a little bit crowded, so I'll draw it over here. We go to line 5. All right, so fib2 calls fib n minus 1. Now we got fib1. All right, now let's see what happens. So fib1, it enters here. Is 1 less than or equal to 1? Well, 1 is equal to 1, so of course. So we return 1. Notice we return. That means that the function is done. We are done executing this function, which means that since we have returned a value from fib1 back into fib2, since we're done, it's popped off the stack. So now we're back in fib2 because we always look at the top element. So we're back at fib2. Now fib2 is done line 5 because it got fib1. Now it goes to line 6 and it calls fib0. I'll color in green as well. So we call fib0. 0 is less than or equal to 1. Of course. So return. Same thing. Now that it reached this return line, it's done executing. So we're done. So that means that fib0 has popped. Now, look at this. This is the first time we reached line 7 of the program. And just like that, we now have the contents of the call stack that we're looking for. So the contents of the call stack, just before the very first time line 7 runs, is this. There we go. And you can do more things. Let's say we want to say, what about after the first time line, let's say after the first time line 5 runs. So now I'm saying after the first time. Let's go back to fib3 to make it simpler. So fib3, we reached line 5. This is the first time we reached line 5. So we call fib2 like this. So now we have is 2 less than or equal to 1? Nope. So red reaches here too, and we call fib1, which I'll put in blue. Is 1 less than or equal to 1? Of course. So we return. We're done executing fib1. So that's out of the stack. Now look at this. We go back to fib2 and we just completed running line 5 for the first time. So this is the contents of the call stack from like just after the very first time line 5 is executed. Alrighty. So that's for this equation. Now let's do something a little bit different. Let's take something like this. We have 2 functions this time. So again, let's say we call, so we have main, of course. Main's in the call stack. Let's say that we call bar 4. Why not? What is the contents of the call stack when it reaches line 12? Well, let's see. So we call bar 4. So the equation enters here. So we int y equals 10. We go to line 11. We call foo at x. So we call foo, which will make it a red. Foo at 4. So 4 less than 5? Absolutely. We return 0. So we have now exited foo 4. So that means that is popped off the call stack. Then we get to this line, y plus equals x times z. But look at that. We just reached our target line. So that's the contents of the call stack from the first time line 12 is run. How about, let's do something interesting. How about line 5, where it's just some blank line? How about from the first time, during the first time line 5 is executed? So of course we ran bar 4 again. Tracing, we get int y equals 10. Okay. Then we call foo at x. So we call foo, let's make it red, foo at 4. And check this out. So we reach here, and 4 is less than 5. Of course. So return 0. So that means that this is popped off the call stack. So we haven't reached line 5 yet because foo at 4 terminated here. We didn't reach line 5. So now we're back in bar 4. Y plus equals x times z. Well, z was 0. We returned 0. So y is still 10. But now we call foo at x plus y. X is 4 and y is 10. So we call foo at 4 plus 10, or 14. Alrighty. Now, if 14 is less than 5, that's what we're checking over here. Well, that's absurd. So we exit this if statement, and look at that. We reached line 5 for the first time. And this is the contents of the call stack from the very first time we reached line 5. So I hope this helped. We just went through a couple examples of the call stack, given one recursive equation like this, and then 2 different methods like that. So I hope this helps with your understanding of the call stack. Thank you so much for watching, and have a good day.